what is vector? And according to the contributions by the two contributors, then says anything that has a scalar and that has dimension, right?
Dimension.
Yes, that's dimension. So let's look
Yeah.
at it this way. A vector on its own is just like anything that has two operations. You can
Yeah.
add the two of them,
That's that.
you can multiply them. Two operations, that is homogeneity and additivity. So you can add it, you can multiply it. Those two operations that a vector contains, you can either add them or you multiply them. The ones you can multiply, they are the scalars. That is the scalar quantities and so on. So now, our concern here tonight is vector space, not vector itself. But you know, it will be very, I think we'll be speaking above ourselves if we don't even know what vectors are. And we're talking of vector space or spaces. That's why we did justice to vector at the beginning. Now to vector spaces, and the definition is somehow clear. But let's look at it like this, that a vector space is like a collection of vectors. Not just one vector now. Collection of vectors. And just the same thing you can do to vector, which you can add vectors. In vector space too, you can add two vectors in the space. You can multiply any vector by another vector or by any number, which is the scalar. You can multiply the vector and the scalar. But everything you are doing will fall within the space. That is how we say vector space. I'm just trying to explain this definition. Everything you will do in the vector space, whether you are adding or you are multiplying, it will fall within the specified space that you are working with. It has a rule actually, or it has a set of rules. But okay, let's leave mathematics now and come to maybe real life experience to want to grab the image very clearly. Let's say we have a club. Let's say this our infotech now. We form a club of our set like 2020. Is that 2024 or what's that? What is that set again? 2024, right? So let's say we form a club and we set rules, and every member must obey the rules that we set in that club. And then addition and scalar multiplication must not produce outsiders, which means if we say that the age bracket for, let me not use age, let me say, okay, this is our infotech club. The only set of students that we want to have there are those that are having A's and B's. If you are getting C, you are not part of us. I'm just saying. Okay, if we add within our club, within that space, within that group, our addition must yield someone who is getting A and B. If we multiply, our multiplication must yield someone who is getting A and B. So any operation we do within that club must fall within the club, not giving us a value that is outside the club. That is vector space that we're talking about. The simple idea of vector holds, which is addition and multiplication, but it holds within a space, which means if I'm dealing with a space that is on, like this example that they say, when you are dealing with Z4, you know that I think this is under rotary something, mathematics. When you are doing rotary calculation, what do you call them? That particular module that you are dealing with will not appear in the element. So if you are dealing with module 4 will be 0, while 3 will be the highest value that you will get in module 4. If you are dealing with module 5, 4 will be the highest figure that you see there, just like that. If it's module 6, it's like that. 5 will be the highest. You start with 0. So in this module 4 now, the space is from 0 to 3. If you are this is a vector, assuming if you are to do anything on this vector now, whether we're adding or we are multiplying, it must fall within this 0 to 3. You can't get 4 here or 5. It won't fall. because it's outside this 4 here itself is outside this space. 5 is outside this space of Z4. For Z5, 5 is outside the space, 6 is outside the space, 7 is outside the space, and so on and so forth. I think we should do something very clearly to explain this place a bit. I would need to share my, where is that book? Can we do that in 9 minutes? I think we can do it. So I'll first need to stop sharing my screen. I want to give us an example that is outside this material, but just to, it's still vector or whatever we're doing, vector space, to help us to understand what we are saying, that what we are trying to say, that when you multiply or when you add within the space, it must not go outside the space. Consider a vector. Don't mind my handwriting, don't laugh at me. Consider a vector that we have like this. Let's say 1, 2. Sorry, that is not comma again. That is the end of it, so no comma again. This is one vector, and we have another vector, for instance, 0, minus 4. Then let's say we have another vector, 3. Let me know. Let's say 3.5, yeah, comma 7, and so on. No, let's just say this. This is a vector space now. Now, if you are to add within this space, let's say we add the vector 1, 2. We add it to let's say 3. No, that is comma. I'm supposed to put the addition here. We add this vector 1, 2 plus this vector 3, 4, for instance. You know we are going to get 4, 6. Is this vector, this resultant vector of the addition of these two, is it within this space or not?
Yes, within it.
Thank you. That is what we are trying to say. Because this our vector here, or these vectors we are dealing with here, we have 1 to 7. So this is definitely within the space. That is what we are trying to do, what we are trying to say in vector space. So if you do multiplication too, you have something to say?
Are you sharing your screen?
Are you not seeing my whiteboard?
I'm not seeing anything now.
It's from your end. You need to.
I can see it. I can see it.
I'm writing on my whiteboard. Sorry, I stopped sharing the screen. So, but I'm using the whiteboard now, so you should be able to see it. It's true that tell me that it's only 2 people that are following me. I can see it here too. Try to, maybe it's your setting there. Now, the first one we did is for addition. But you know that in vector space or spaces, we can do addition, we can do multiplication. What if we want to multiply? Let's say 3. Oh, sorry, I'll need to pick on pen now. Let's say you are given this vector to work with. What will be the result? 3 times 1 will give us 3, right? Then we are going to have comma 6, right? Now we've done multiplication. This multiplication, is it within? Oh, sorry, that is too far. Is it within our space, or the result we get? Is it within our space or outside the space? This is our space. All these vectors here, 1 to 7.
It's still within, because it's not greater than 7.
Thank you. That is what we are trying to do in that idea of vector spaces. So that it doesn't look like we are speaking from China or something in your face. It's as simple as this. Vector operations, something that deal with 2 operations, addition and multiplication. Then space, a limit that has been said that this is where every operation you want to do on these vectors must fall within. If it falls outside the space, then it's no longer under that space. So let's stop this, and I think even stopping this. Okay, let me give room to room for questions, because I can't move on to the next we want to do. We have just 4 minutes. We have to restart this class because we wasted a lot of time trying to set up. So let me stop this one. Now, if you have anything you want to say on what we've done so far, let me know before we move on. We'll actually end this class and we'll restart it. But let's use the 4 minutes to ask questions on what we've done so far.
So far, so good. On my end. On my end.
Okay. Let me give us another practical example. We used club the other time. We have ladies here, so let's use food now. Let's say, for instance, you are cooking a Nigeria recipe or something. And then, let's say within your recipe, we have rice, we have beans, we have yam, which is, each of them represents a vector. Now, when you add them together and you mix them, you get food. If you double them, like probably you multiply them by 2, let's just say like you double the amount, the quantity that you are trying to work by, you will still get food. For instance, and maybe you cooked just 1 cup of rice before, and you mix everything together, you get food. When you cook 4 cups of rice, you still get food. It's still fall within rice. It's not the food you will get is not outside rice. So that is what we're trying to say. So if your recipe is rice, beans, and yam, you can add rice to beans. Let me not confuse you. I think it's okay like that. So any question? I think we still have 2 minutes. Let's stop that. Now, in Z4, Z5, we define addition and multiplication respectively as this is the addition 0, 1, 2, 3. This is what we're adding. No, we're adding this to this. No, sorry. This is 0, 1, 2, 3. We're adding to this 0, 1, 2, 3. We understand what we're talking about. This is the operation we are dealing with. Addition. We are adding this first line, this 1, 2, 3, to this 1, 2, 3. So which means, how is it going? We are going to say 0 plus 0, right?
Yeah.
That one gives us this, right?
0.
0 plus 1, it gives us 1. 0 plus 2, 0 plus 3, all will just give us 1, 2, 3 back. Now let's come to 1 now. 1 plus 0, it still give us 1. 1 plus 1 will give us 2, right? It's just the normal addition. The only thing is that once you get to any number that is beyond the space we are working with, we represent it by 0. For instance, this is 1 plus 2, 3, right? Then 1 plus 3 is 4. But 4 cannot appear in space 4. So to represent 4 in space 4, we are going to have 0.
Mr. Sam.
Yes?
In this case, are we dealing with 4 or 5? So is it that if it's higher or equal to 5, 4, or higher or equal to 5? So which one are we dealing with?
You can't have 5 in space 4. Just know that one. The highest width you can get in space 4 is 4 digits. And even the fourth one will be 0. That one is a rule already. The same thing in space 5. Okay. You cannot have 6 digits there. You can only have 5 digits. And the fifth one will be 0. Under the law or rules